as you can see, we have been discussing continuity using different examples, and some of these are not continuous, or in other words, they exhibit discontinuity at a number or at an interval. Okay, so this can be classified into three types of discontinuity. First, we have the removable discontinuity. Second is the jump discontinuity. Then the last one is the asymptotic or the infinite discontinuity. Okay, so let's define each one. Okay, removable discontinuity occurs when there is a hole in the graph of the function. As the name implies, we can remove this discontinuity by redefining the function at the point of discontinuity. Whereas the jump discontinuity occurs when the graph of the function stops at one point and seems to jump to another point. In a jump discontinuity, the left-hand and the right-hand limits exist but are not equal. Okay, so literally speaking, when we trace the function of when we trace the graph of the function, and then there is a point where we lift our pen, then we can see that this is a jump discontinuity. Okay, we lift our pen in order to proceed to another part of the graph. Okay, whereas the asymptotic or infinite discontinuity occurs when at least one of the two limits is infinite. Now let's have some. Now consider f of x equals 2x squared plus 11x plus 5 all over x plus 5. A while ago, we were able to determine that this function is discontinuous at x equals to negative 5. Okay, so this time we determine what kind of discontinuity would this graph or would this function have. Okay, so as you can see, using graphical method, you would be able to have this kind of graph in which x equals to negative 5 is not allowed because this function will have a denominator of negative 5. Okay, so graphically, we can trace this completely. However, we need to be interrupted by a hole or an shaded dot on this portion. Now, if we will evaluate the limit of 2x squared plus 11x plus 5 all over x plus 5 as x approaches to negative 5, remember that this function is a rational function. So we need to determine whether this is in the lowest term already. So we factor out the limit of 2x squared plus 11x can be factored as 2x plus 1 times x plus 5. Okay, so as you can see, this will have, we can cancel the denominator x plus 5. So simply, we will be evaluating 2x plus 1 as x approaches to negative 5. Now, take note here, 2x plus 1 is already a continuous function at x as x approaches to negative 5. So in this case, this implies that we can remove the discontinuity of this function. Thus, we redefine the function at the point where the function is discontinuous. So we will have a removable discontinuity in this case. Now, in order to redefine the function, we have to have the constant function negative 9, where x is equal to negative 5. Hence, we can already say that f of x is continuous at any point on the graph. Okay, so that makes sense why this kind of discontinuity is called removable discontinuity. Okay, so let's have another example. Let's determine the type of discontinuity exhibited in f of x equals x squared minus 1 where x is less than 2 and x plus 2 where x is greater than 2. Now, using a graph or using its graph, we would be able to see that if we trace the graph, okay, we will be interrupted by this hole, then jump to another point in order to trace the other part of the graph. So in this case, we will have a jump discontinuity. We cannot remove the discontinuity in this kind of function. Now let's have example number 8. Determine the type of discontinuity exhibited in f of x equals 1 over x squared. Now graphically, we can see that as we approach or as the value of x approaches to 0, the value of f of x approaches to positive infinity. So by definition, we can conclude already that this graph is discontinuous and the kind of discontinuity would be asymptotic or infinite discontinuity. Okay, by definition, at least one of the limits is equal to infinity. Okay. Now let's have a recap of our lesson for today. There are two main concepts that we have learned. We have continuity of functions, which literally means tracing the graph of the function without lifting our pen. We can also use the three-step method in order to determine whether a function is continuous at a number or not. With this, we need to satisfy three conditions, which are f of a exists, the limit of f of x as x approaches to a exists, and that the limit of f of x as x approaches a is equal to f of a. When these conditions are satisfied, then we can conclude that the given function is continuous. Whereas if any one or more of the given conditions were not satisfied, then we can say that the function is discontinuous. So when this occurs, there are three possibilities. Okay, the first one is the removable discontinuity. Okay, by the name itself, it implies that we can remove the discontinuity of the given function by redefining the function at the points of discontinuity. Second is the jump discontinuity, in which when we trace the graph, the tracing pen or we lift our pen in order to trace the other parts of the graph. Lastly, we have the asymptotic or the infinite discontinuity, in which it occurs when one of the limits is equal to infinity. So thank you for being with me in today's lesson. Hope to see you again in our succeeding lesson. Good day.